All right, congruent triangles. All right. So we've talked about congruent angles, we've talked about congruent segments, we've talked about all sorts of ways of thinking about congruence. All right. Now, with a congruent triangle, though, what we're talking about is every single thing about these two triangles is identical. All of their angles are the same, all of their sides are the same, okay? So, that straight away leads us to say, okay, well, first of all, how much do we have? We've got 3 sides, and we've got 3 angles for any pair of triangles, right? Actually. All right, so we have 2 absolutely identical triangles, and let's call them C and L, M, N. Okay, if these 2 triangles are congruent, that means that all of these parts are congruent to all of these parts. Okay? And what we have is, just like we had when we were talking about congruent angles or congruent segments, we had a way of writing the description of that using symbols. Okay? If I wanted to say that, segment AB is congruent to segment LM, we would say AB with a congruent sign LM. Done with it. But with a triangle, however, we have a little bit more. So there we have the symbol, the little baby triangle, to say, hey, I am talking about the triangle ABC, not the angle ABC or the plane ABC or anything like that, but the triangle ABC. Now, we write our congruent symbol, and the other triangle, well, we want to make sure that the right parts are going to the right parts. So A is congruent to what angle? L. And B is congruent to M, and C is congruent to N. So this is what we call a congruence statement. And a congruence statement tells me a lot. It says that this part is congruent to that part. Okay? And so A corresponds to L, B corresponds to M, and C corresponds to N. Okay? Now, the way I drew these, they look exactly the same. They're both pointed the same direction. Everybody looks exactly the same. That's probably as simple as it's going to get. But I could spin them around. I could flip them. I could make them touching. I could make one overlap the other part of it. I could do all sorts of funny things to make these pictures look maybe not identical. And what you need to be able to do is say, hey, because of the things I already know, I know that those 2 triangles are congruent. Okay? So, for example, I could do something like this. And this is just an example. You don't have to copy this right now. You just kind of have to watch it for a second. All right, so, and I'm going to make sure that that's actually the way I want it to go. Oh. Hey, just because I said you didn't have to copy it doesn't mean you shouldn't be paying attention. All right, so they may not look like it right away that those two are congruent, but you saw me make them. You saw me clone it. All right, so we know, because we know something about vertical angles, right? We know that these two are congruent right away, just because they're vertical, right? Okay, and we also know other things. We know that all right angles are congruent to each other. If you think about it, every right angle is 90 degrees. We're doing math in this class, so please put down your other homework. Thank you. So, there are things that we know about, excuse me, this is where we're paying attention. There are things that we know about certain geometry shapes that are useful to us in saying, hey, those are congruent, okay? Now, there are different ways to prove things congruent, to show me, to convince me that two triangles are congruent. Because there are three angles and three sides. And I don't really need all of them. For example, if we go back to this piece, if I just took out those for a second, could these triangles not be congruent? All I'm saying is that I don't know anything about C and N anymore. I know about the sides, I know about the other angles, but I never went ahead and found out what what C and N were. Could they still be congruent? Yeah, in fact, they'd still have to be. Because if you think about it, whatever the heck A and B are, they're the same thing as L and M, right? So just because of the properties of adding up the angles in a right triangle, right? If this was, say, 45 and this was 50, this would have to be 45 and this would have to be 50, right? Still. Well, that means that automatically, by default, I know what C and N are, right? I just subtract from 180 in both places, right? Now, in fact, we don't even need that much. We need a whole lot less. If I didn't know those, I could still do it. Because no matter what they are, no matter how long they are, those two segments are still going to come up and intersect each other, right? No matter what, because I fixed L and M. L and M are a certain size, and that means that those two line segments are eventually going to bump into each other down the road, okay? So I don't even need to know how long LN is or how long NM is, because eventually they'll make a triangle. And that triangle is going to have a specific angle at the other end, which is still going to be the same as the other guys, you see? So there's a very little amount of information that we absolutely have to have in order to prove that two things are the same. And there are different combinations of those things. And this is a very important list. And I want you to just write it down, and I'll go into each one of them at first, okay? There's a good list. And there's a bad list. Yeah, there are ways to prove things that are acceptable, and there are ways of trying to prove things, but they don't work. This stands for side, side, side. If I know all three lengths, I can make a triangle, and I can prove that if I know those three lengths and you have those same three lengths, we're going to make the same triangle. We also have side, angle, side, angle, side, angle, 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 side, and there's a weird one that we're going to talk about called hypotenuse leg, and we're going to go into all of these. Yeah, I want you to write the abbreviation. But you should know this is hypotenuse leg. All right, that's what the H and the L stand for. Remember, the hypotenuse is the biggest length in a triangle. It's the one that's across from a 90-degree angle. Okay. There are some on the bad list, and we'll go into these first because we're not going to have to worry about them, except we want to know that they don't work, so that if we see them, we can say, whoa, that doesn't work. Can't do that one. Here's one. Angle, angle, angle. If you give me three angles in a triangle, I'm not going to be able to prove it. And here's a simple example. Better yet. Take that triangle. Okay? All the angles are different, but between these two triangles, those two triangles right now are perfectly identical, right? I just cloned it. And if I know, say this is 100, and this is 30, and that's 50, this is 30, and 100, and 50. Okay? They look congruent. They're still congruent. I haven't done anything to them. Are they congruent anymore? No. Because congruent says everything's the same. And this guy's obviously a heck of a lot bigger. But its angles haven't changed. Right? So angle, angle, angle isn't enough. I need to have an idea about how big it is too. And you'll notice that all these guys have a side in them. So that tells me just how large of a triangle I'm playing with. If you think about an equilateral triangle, for example, we know that all equilateral triangles have what angle? What's the angle in an equilateral? In an equilateral. Come on now. They're all equal. What's the measurement if they're all equal? We know this. 60. Thank you. They're all 60s. All of those have the same three angles in them. But are they all congruent? No. They have to be the same size. So angle, angle, angle just doesn't work. Okay? That's why it's on the bad list. Oh, wrong one. All right. The other one is easy to remember. And I'm going to write it in reverse. And we call this one the Donkey Theorem. Because there's another name for a donkey. So, side-side angle doesn't work. And we're going to go into an example of why it doesn't in a minute. So those are the two on the bad list. These are all the ones on the good list. Okay. So, why is side-side angle on the bad list? Here's why. Here is an angle. I have to use that angle, exactly that angle, when I make my triangle. Okay? I also have to use those two lengths. Okay? So maybe I have two pieces of wood and a hinge. Okay? And I have to make a triangle out of them. Here's the problem. A second. I'm going to have a problem with that one. All right, so I had to change my length because it wasn't going to work for me. But that's my side, that's my angle, and that's my other side, and I have to use them. So if I try to build it, the problem now is this guy could swing, right? It could be anywhere around here, right? Well, uh-oh. See, I don't know how big that third side is. That's why I'm making it a dotted line. But I know that I've got that angle, and I know I've got those two sides. They have to be that way. Head up. But this guy, I don't know where he is. He could be anywhere around here. And the problem is it that triangle? Or is it that triangle? I don't know which, and neither do you. It could be either one. It's not enough information. I need one and only one possible triangle. If this leg were shorter, maybe, you see, now I'm still going back and forth, right? And if I shorten it a little bit more until it was exactly a right angle, straight up and down, now I've only got one triangle. Now there's no, now, when it swings, it only touches at one point. And this is why this is the hypotenuse leg. So hypotenuse leg happens when you have its side-side angle, but you have a right angle. All right. So this is the one exception to the angle, to the side-side angle, to the Donkey Theorem. Yeah, a little bit slow. Yeah, I know. Yeah. Moving on. So it's the exception to the Donkey Theorem. You have to have a right angle in hypotenuse leg. Now that does not mean that just because you have a right angle in your problem does not mean that you automatically have hypotenuse leg. But you can't have hypotenuse leg without a right angle. It goes in one direction, doesn't go in reverse. Okay? If you will remember what that means. All right, so now let's figure out how can we tell. Now here's what's going on. Oops. Nope. Actually, that almost looks like isosceles, doesn't it? All right. Okay. Now, if we have to have some information. Hey, play nice. All right. Yes, you should be drawing this. Now, we need to find out what method of proof works for these. So we have to first decide, is this side, 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 angle, side, angle, side, angle, side, any of those others? We got to make a choice. Okay, here's how you choose. There's a rule, and here's the rule. We don't have gum. That's the rule. But there's another rule. Yeah, no, she was being slick. All right, here's the rule. You cannot skip over two unknowns. Let me explain. And I should say two consecutive unknowns, two next door neighbor unknowns. All right, what the heck does that mean, Ronco? All right, here's how we do this. Let's go through this triangle, PQR, because we know some lengths because we have tick marks. We know that angle Q is congruent to angle X. That was known, right? We don't know about QR. There's no tick mark on it. And there's no rule that allows me to say, oh yeah, because of this I know that. There's no reason why I would know that QR and XZ or any other length are equal, right? I do know about PR. Yes?
Yeah.
What is PR congruent to? Which one? YZ, right? Because of the tick marks. They tell me that. All right. Do I know anything about angle P? There's no mark on it. There's no vertical angle on it, right? There's no right angle, because remember, all right angles are the same. They're all 90 degrees. There's nothing that says to me, hey, I know something about P. So let's go around this thing. I know angle Q, right? Do I know QR? Do I know what that is? There's no tick mark on it, right? There's no rule. That's an unknown. What about angle Y? Do I know about it? Yeah, I got a tick mark on it. We're good. PR? Yeah, I got a tick mark on that one. Angle P? Do I know angle P? I don't know angle P. What about PQ? Do I have any? No, I don't know anything about it, do I? Right? So that's an unknown. So what we want to do is we want to connect those three check marks. And the rule says that you stay away from two question marks that are next door to one another. If you avoid those two question marks, this part right here is what I'm talking about. If you stay away from that, you'll be okay. Now all we have to do is connect the things that we have. Side, angle, angle. But wait, why don't I go the other way? That's fine too. What do I get? They're both the same. It doesn't matter because I can flip this triangle any way I want to and walk around it in any way I want to, and I'm still talking about the same triangle. So you can go in reverse if you want to. Is this on the good list or is this on the bad list? It's on the good list. Now we're going to go through this other triangle and we're going to make sure that it's also the same thing. Because if I'm side, side, side on one triangle and angle, side, angle on another triangle, I don't know. They got to be the same rule. Okay? So, I know this. I don't know that. I don't know that. I know that. I know that. I don't know that. We're going to stay away. And what do we get? Angle, angle, side. They're the same thing. So yes, these two triangles are congruent. Do you see that path that we have to take? All right, now how can we do a congruence statement? Triangle what is congruent to triangle what? Let's do triangle. The first one doesn't matter how I go. Let's just go PQR. Who is triangle PQR congruent to? What does P go to? Y. P goes to Y. Q goes to who? Q goes to X. And R goes to Z. They don't have to be pointed the same way. They don't have to look alike, and they most often won't. So this is how we do it. We decide what we know. We connect the dots, so to speak. And they have to be the same method. All right? So, let's do a different one. Okay, pass. If I'm drawing it, you should draw it. All right. Well, what are we going to do about this? I mean, just look at one of those triangles by itself. I've only got 2 tick marks on any one of those triangles, don't I? Can I do anything about that? I think I need at least 3, right? Everybody needs at least 3. Oh, I got verticals. And because I have verticals, I can add a tick mark. You see? I didn't have it at first, but because I know something about a triangle, and I know about angles, and I know how certain things work, I have some knowledge. That knowledge can go a long way to adding tick marks that normally wouldn't be there. Okay? All right, now let's look at one triangle alone. We know A, right? We know AB. And now we know this angle right here, ABE, right? Do I know BE? No, I don't know that. I don't know angle E either. And I don't know AE. Right? I don't have any of that. So now, if I can't skip over 2 unknowns, you think I can skip over 3? Heck no. So, what would this be? Connect them. Angle, side, angle. And that's on the good list. And look at the other triangle. Is that angle, side, angle also? So that's how we would prove these, with angle, side, angle. And now we're good. That's all we have to do. So this is the first of this whole unit. You've got to be able to, first of all, you got to be able to pick out what method of proof it is. And that's what we're learning how to do. And you also got to be able to write a congruent statement. Okay? So, take a second, everybody write a congruent statement for this guy. And we'll start off by saying triangle ABE is congruent to triangle what? Now it's what you got to write down. Figure out what ABE would be congruent to. Yeah. So, who's got an answer for me? Yell it out. Everyone. CBD. Okay. So triangle ABE is congruent to triangle CBD by the angle side angle method, or angle side angle theorem, basically. Is that working? Okay. All right. Next one. Okay. Now, Okay. Well, let's go into this one. Yeah, it's a U. They share a side, right? Okay, now that's interesting. That they share a side. So that RO side, right? So if you're talking about the left-hand triangle, it's got a segment in it called RO. And if I'm talking about the right-hand triangle, it's got a segment called RO, right? If you thought about them split up in your mind, those ROs, would they be different? No, they're the same thing, right? They're made from the same length, right? Whatever the heck RO is, if RO is 10, then the FR triangle has a 10 in it, and the UOR triangle has a 10 in it. You see? If I split them up, they'd still be the same. There's a name for that. It's called the transitive property, or the reflexive property, sorry. Right. The reflexive property says that if these two pieces are, if this piece is shared by two things, then it's in them both, and they're still congruent to each other. Okay. We'll use the reflexive property for sides, like this, where they're shared. And sometimes we'll use it for angles, too, and we'll talk about those. So that's great. We added a tick mark. If we talk about the left-hand triangle, it's got a double tick mark. We talk about the right-hand triangle, it's got a double tick mark. Both triangles have that same piece. But I still don't have enough. I need 3. How can I add another piece? Well, let's look at what the problem says. Well, we don't know that yet. We don't know that they're identical. We want to know that they are. Yeah, they sure do, but that doesn't mean that they are. Why? Ah, okay, so wait. She's got an interesting point. They told us that RO bisects angle FRU. So that means, what does it mean? What does it mean to bisect an angle? Well, what angle? Go up there and mark it up. If something bisects something, that means, right. Nicely done. Round of applause. Round of applause. An angle bisector. When somebody bisects an angle, they're cutting it into 2 equal parts. Right? So that means that that left-hand angle and that right-hand angle, they're the same because it was cut right in the middle. Cool? All right. So now, let's look at each triangle, because now each triangle has 3 pieces. And what do I have? I know this, I know this, I know this. What do you call that? And is it true on the other side? So, write down a congruent statement and tell me that it's congruent by side angle side. And let's all start off with triangle FOR is congruent to who? The F corresponds to the U, remember. The O corresponds to the O, the R corresponds to the R. By what method? How's that feel? Is that impossible? Do we know what we're doing? All right, good. Let's try this one. Um, actually, yeah. What about this one? Yeah, the other side, the LMQ, that's a right angle also, isn't it? So I was able to add that tick mark, even though it wasn't in the original problem. Because we know something about right angles, right? And we know that those two right angles are congruent to each other because all right angles are congruent. Which one? The shared side. What property, what do we call the name of that when that happens? The reflexive property. The reflexive property tells me that. So now if we look at one triangle, either one, the left or the right, let's go through it. Okay, so now I've got all this stuff. Why don't you try this one on your own and see what it is? Look at it. Write it down. Figure it out. What is it? So what do you think it is? Nice. Nice. All right. Some people got it. A lot of people were saying this. It is because we don't know that, but we don't know that, and we don't know that. And if we can, but we know these. And if we connect them, we wind up getting side-side angle, right? But that's on the bad list.
It is? Yeah, it is. But then we get that right angle.
But it's a right angle, which means it's the exception, and it works as HL. If it's HL, it is not side-side angle. Side-side angle is on the bad list. If you left it as side-side angle, that's you telling me, hey, it doesn't work. You need to really say that it's HL. If it's HL, you say so. HL and side-side angle, one might be an exception, but one works and one doesn't. Okay? It's important. So write me a congruent statement. Let's go LMQ. Triangle LMQ is congruent to who to who?
You said M. You said M. It's M.
That's what I said.
NMQ. Don't draw this until I'm done with it. All right. We don't know anything about it yet. We don't know anything about it. Do we?
Do it. Did you say do it?
Do we?
Oh.
All right, now let's look at this, because this one, and I chose the letters of this shape particularly because it is a nasty problem. N-A-S-T-Y, right? Ha ha ha. All right. Now, when you have two triangles, yeah, sense of humor is flowing in abundance today.
I didn't get it at first.
Uh-huh.
It's supposed to be nasty. Because it's a nasty problem.
It is a nasty problem. All right, so let's go through this. When you have two triangles that are overlapping, ladies and gentlemen, it is best to draw them yourself separated so that you can put tick marks in them and look at it in a lot easier way. Okay? So if we take this thing and we split it up into two pieces, into two triangles, right? It would look roughly like this. And let me just move everybody over and get some more room here. They would look like right? That's kind of lousy. It's hard to draw when you're that close to it. They kind of look like that, right? If I was to take the two triangles and split it up.
What about? Talk about views.
I have this triangle, right? And I've got that triangle.
Oh. Okay.
Go ahead. That's all right. This is a nasty problem. No, there's no such thing as a stupid question. Okay, ask it. Yeah, that's not. Oh, he's got the pass. Great. Okay, so now we can start writing tick marks and stuff. What can I mark up? Which, yeah, but actually, we don't even need to, this point right here, that's not part of any of the triangles, right? But that's a good question. What can I mark up? Is there anything? Put it away. Phone away. What can I do? Can I mark anything? Why? What? What can I mark up? TA is congruent to SY. And I know that because they gave it to me. It was given. read the directions, right? What else can I mark? Angle S and angle T. Can I mark anything else? Really? YN. What do I know about angle N? Why is it congruent? Because they overlap each other. And if it's the same part used in both triangles, it's congruent to itself, isn't it? I mean, I am congruent to me, right? But I am myself, right? You know, so if there was a clone of me, well, twins are a little bit different. But if there was a perfect copy of me, right, then everything would be the same, right? That's the reflexive property. The reflexive property works not just for shared sides, but for shared angles too. All right, what do I got? How are these congruent? Write me a congruent statement. And what method of proof? Give me TAN. Who is TAN congruent to?
Tan is congruent to
SYN. By what method? By who? By side angle. Angle, angle, side, or side, angle, angle. Either way. Right? You could have gone this way, or you could have gone that way. It wouldn't have mattered to me, because it is angle, angle, side. They're the same thing. It doesn't matter what order it is. If I see that phone again, it's mine. So, are we okay? Not impossible? You understand it? Let's do some more. Oh. I don't want to do it. All right. Let's, how about this? Everyone stand up, take a break, stretch. Stretch. Get a few seconds, get some blood flowing. Actually, how about this? Everybody stand up, except for Desmond. Everybody stand up. And let's confuse the living daylights out of Naomi when she comes in. Everybody sit on the opposite side of the table. Everybody go to the other side of the table. Not the other side of the room, the other side of the table. So you two switch with you two. You all switch with these people. Everybody switch. Let's confuse the daylights out of her. She's going to walk in and be like, what happened?
I would be sad.
It feels weird, doesn't it?
I like it.
Sit on the other side. That's okay. You can sit here. Or actually, you stay put, because you would. Guess what? By the reflexive property, you're staying right where you are. Okay. All right. Let's do one more. How about this one? Okay. How about all right, now, how about if I say, if you want to, let's do one problem where we're currently sitting. Maybe you'll enjoy sitting on the other side of the tip.
No.
If you want to. All right. So this was given to me. This was free. Free things are good. Okay. That was given to me. What can I immediately put down on this piece of paper? Well, that was given, so I'm going to use it. That's free. What else? What did we call it? The reflexive. We don't know. Congruent does not mean, parallel does not mean congruent. You can do that one. That one's also free, right? By what property? The reflexive property. MQ is congruent to PN because it was given to me. And NQ is congruent to QN because of the reflexive property, right? Okay. Uh-oh. I don't know what to do now. I need some more parts. What is this? What does that mean? Whoa, what's that symbol? That's the parallel symbol. You're like, wow, Ronco, I thought we were done with parallel. Ha, no. It is. This is a retro math problem. We're going back to parallel for a minute. Okay, but parallel does not mean congruent, does it? Parallel doesn't mean congruent. Heck, I'll show you two parallel lines that aren't congruent. There we go. They're parallel, but they're sure not congruent. One's big, one's small, right? So parallel doesn't mean congruent. But parallel does tell me something about angles, right? I know some angles in parallel lines. Like, remember, if you go back to that picture, we knew that, corresponding angles were congruent, and we knew that certain other pairs might be congruent.
Oh! That's the alternate interior. Yeah. What you say by interior? Yeah. That means NQ is
Wait.
like this side.
Process it.
Yeah, it is. Yeah, it is. Equitable Q is the same way.
What do we call those?
Same side, alternate interior.
Alternate interiors. And what do we know about alternate interior angles? They're congruent. Alternate interior angles are congruent. Parallel lines give you angles. Yeah, I know. It's a weird one, right?
Yeah.
What method of proof? What method of proof? Is that good?
That's bad boy.
That's that one, right?
These are not congruent. Even though we would have liked them to have been congruent. Yeah, I know, but not everything works out for us. I know. If we go through it, look at it again. I don't know that. I don't know that. I know that. I know that. I don't know that. And I know that. If we connect the checks and stay away from this, if we stay away from that, we go side, side, angle. It doesn't matter. You go either way. Yeah, if you go from here to there, you get side, side, angle. If you go from here to there, you get angle side. Right. If it had a right angle in it, that'd be a totally different story. And then it would be congruent by what? HL. Right. He's got it. Yeah, carry the pass. It's somewhere around there. Do you still have the pass? It's over there? Okay.
No.
What are you talking about? Huh?
I know you're not going to cross that.
No, of course not. He wouldn't dare. Of course not. Huh. Hmm. Hmm. Let's process this. Yeah. Math teachers have lots of problems. All right, right, yeah. So as soon as you see parallel, you should be looking for what? What did we see in the last one?
Angle.
What kind of angles? Alternate interior angles. And here's how you can find them. Here's how you find them. Right? You can see where they are, right? Somebody name me one of my alternate interior angles. Give me the name of it. What would you call it? Yeah, like give me the three-letter name for one of my angles. Well, RET would be this one. What would it be? RTE. This guy is congruent to that guy. Right, you see, you draw your two parallel lines and you look at the line connecting them, and that'll help you see it. You see, what you're really looking at is this. Yeah? Okay. Anything else I can mark up? Who can I mark? What can I mark up? Hash marks in the middle. By what property? The reflexive property. Blah, 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 blah. Right, yeah. So, do I have enough? Do I have enough? Can we begin?
No.
What? Can I? What would it be?
No.
Yeah, you got the right, you got the 93.
Well, the chair has the side.
The what?
Like this.
They are parallel, but that doesn't mean that they're congruent, right?
I mean, I'm trying.
I know. Well, let's look at each one by itself. Okay? Let's look at each one. If I were to take those two shapes, those two triangles, and separate them, that's what they would look like, right? Yes, it is. Guys, play nice. What's this one called? Angle, angle, side. Connect, check, 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 right? Or side angle, angle. It doesn't matter to me. Say it again. You can reverse it. You can reverse it. Either one is fine. So, give me a congruence a congruent statement. Who is congruent to who? R goes to who?
C.
C. Who does E go to? Oh, no, that's not R. Sorry, that's T. Shh. All right, calm down over there. You're getting a little excited. So, if R goes to C, let the tick marks help you. Okay. Look. Shh, watch. R goes to C, right? Because that's the right angle. Right? R goes to C because those are the right angles. Right? E doesn't have a mark on it. So who does he belong to? Who does he correspond to? He goes over to T. And T on this triangle goes to E. So they don't necessarily have to go to the exact same letter, especially if it's been flipped around. Because we could... Uh-oh. Hey. All right, how are we doing? It's not that bad, is it? It's problem solving. You got to think about it. You know, you got to take it apart, right? All right, this episode of the Ronco Show has been brought to you by Side Angle Side and Angle Side Angle.